Math 1314, Tyler Junior College, Section 2.3, Linear Functions and Slope. Point-slope form of the equation of a line. In the previous two videos, we defined the slope of a line and derived its formula, applied its formula to a variety of lines, and drew some conclusions about the slopes of lines. Namely, if a line is increasing, its slope is positive. If a line is decreasing, its slope is negative. If a line is horizontal, its slope is 0, and if a line is vertical, then its slope is undefined. But what about the actual equation of these lines? The equation of a line comes in a variety of forms. We're going to study 3 of them. The first is called the point-slope form of the equation of a line. The point-slope form of the equation of a line, which I will abbreviate PSF in future videos, its name describes what it needs to get the equation. I need a point that the line goes through, and I need the slope of the line. For example, we're going to find the equation of the line that passes through the point 2, 5, that's a 2, not a 3. That point passes through the point 2, 5 and has a slope of 3 halves, m equals 3 halves. Now, how can we do this? Well, one way to build the equation of anything is to put a generic point on it and see what that point has to satisfy. For example, let's say that we grab some random point on this line besides 2, 5. We'll just grab one over here, and we'll generically label it x, y. That's a good name for a generic point. What must be true about that point? Well, we know that this point, along with this point together, we can calculate a slope, and we know the slope has to equal 3 halves. So, based on the fact that the slope is 3 halves, I can set up the equation for the slope of a line with a generic point, which could be any point on this line, and this specific point that we were given. So, let's set up that slope equation. How do you calculate slope? Second y minus first y over second x minus first x. Let's call this y the second y, which means that 5 would be the first y. So y minus 5 on the top. And in the denominator, it would be second x minus first x. Well, if I call this the second y, then this is the second x. So our second x, the generic one, is x, minus the first x, which was 2. And that's the formula for slope, but we already know what this is supposed to equal, because we know that the slope is equal to 3 over 2. This is technically a legitimate equation of this line, except for one problem. That equation does not include the point 2, 5. Why? What would happen if you put 2 in the denominator and 5 in the numerator? You would get 0 over 0. 0 over 0 is called indeterminate for calculus reasons, which those of you going there will find out later. But for our purposes, we might as well assume that 0 over 0 can't be assigned a value. Its value is indeterminate or undetermined. So if we left the equation like that, the graph would actually be everything except this line, and it would have a hole in it because we couldn't put in 2 in the denominator. You can't have zeros in denominators. So what can we do to this equation to fix it so that it contains every point on the line, including the point that started the line? Answer, don't have this in a denominator. How do you do that? Get rid of this denominator by multiplying both sides of the equation by x minus 2. So if we multiply by x minus 2, on both sides, on the left it would cancel the x minus 2 and leave us with y minus 5 equals the slope. And on the right side, if we multiply by x minus 2, we would literally have to multiply by x minus 2. Will the point 2, 5 work now? Yes. Because if I put 5 here, 5 minus 5 is 0. If I put 2 here, 2 minus 2 is 0 times 3 halves is also 0. Both sides equal 0. 2, 5 is the solution to the equation. This equation is what's known as point-slope form. It's specific to this problem. Point slope form starts with a P, not an S. And if you'll notice, this equation still has the point's coordinates and the slope intact. The slope was 3/2 and it's sitting right here. The x-coordinate of the specific point was 2 and it's sitting right here after the subtraction sign. And the y-coordinate of the given point was 5 and it's still sitting right here after the subtraction sign. In fact, it really didn't matter what these two numbers were or the slope was. The setup would have been the same, the multiplication move would have been the same, so this structure would have been 100% preserved if we had a generic slope m and a generic point. So let's do that and come up with a generic equation. Point slope form. If a line passes through a generic point, we'll call it x1, y1. It's a generic specific point, which sounds like an oxymoron. But if it passes through the specific point, x1, y1, we just don't know what it is, and has a slope of m, then the point slope form, which we'll abbreviate PSF, of the equation of the line is, well, let's do the same thing we did over there, here, but fast forward to the end. We're going to start with y because our equation will have a y in it. But the 5 was the y-coordinate of the specific point, and the y-coordinate of this specific point is y1. Equals. Over there we had 3/2, but that's because it was the slope. The slope generically is an m. And then open parentheses, x minus. In that question it was 2, but that was the x-coordinate of the given point. The x-coordinate of this given point is x1. And just like that, we've built point slope form of an equation. Let's do one more real quick example before we move on to the next video, which is still be about the point slope form of the equation of a line. But these point slope form problems usually come in a few varieties. The first variety is I'm going to give you a point and a slope. I would like for you, excuse me, I would like for you to build a point slope form of the equation. So let's take out all the extra words. Let's say our point is 19,71, and let's say our slope is m equals, oh, I don't know, let's say 19/93. If you're wondering, are those years? Yes, year I was born, year I got married. What's the equation of the line in the point slope form, which I will abbreviate PSF from this point forward? Well, this is so easy, it's not even funny. All you have to do is fill in the 3 numbers in the correct place, so make sure you know which letters they're replacing. The given point is going to replace the variables x1 and y1, and of course the slope is going to replace the variable m. So you can literally write down point slope form. Y minus y1 equals m times x minus x1. And erase each variable that's going to be replaced, and as you do, replace it. So for example, from left to right, the first variable replaced is the y1, and it is getting replaced with the number 71. The next variable being replaced is the m, and it's getting replaced with 19/93. And then the last variable being replaced is the x1. It's getting replaced with a 19. And there we have it, point slope form. Now some of you might be thinking, wait a minute, aren't we supposed to distribute and stuff like that? Not if the question is, what's the equation in point slope form? In the next video, we'll do one more example of a point slope form equation, and then we'll talk about the idea of distributing and whatnot. Don't get me wrong. We could distribute that slope, and if we're going to do that, we might as well solve for the y. The fraction makes it inconvenient, but not impossible. In fact, I challenge you to come up with the slope-intercept form. Excuse me, we haven't said that phrase yet. I challenge you to take that equation and solve it for y after distributing and getting like terms. At the beginning of the video, the next video, I'll have the results of that on the board.